In this lesson, we'll continue talking about object-oriented programming, specifically inheritance and polymorphism, right? Now, inheritance is the ability to define a new class from an existing class, right? So the existing class, the most general class, is called the superclass, and it is extended to be more specialized, and then it's called a subclass. So superclass and subclass are two terms that we should get to know. So what's an example? So an example, you might define a general geometric object class that can be extended to be a circle, or can be extended to be a rectangle, right? So superclass will be geometric object. It'll have common properties such as color and position and such. And the subclass would be circle, which would extend geometric object. It would inherit all the existing properties of geometric objects such as position and color, but it might add its own specific needs. Like for a circle, you might add radius. For a rectangle, you might add height and width, right? And you might add also additional behaviors, like get area for circle would be specialized for a circle's need, where it might be different for a rectangle. So how would you represent this in UML? In UML, you have the superclass, geometric object, and the subclasses, circle and rectangle. Notice the lines, the arrow that points back towards the superclass. The superclass has common member variables and methods, right, that are inherited by the subclass. The subclass can use the public ones, right? Then the subclass also extends the superclass with its own member variables and methods, right? Okay, let's look at what this might look like in code. So what we are doing in the code is representing this part of the graph. We are not showing the rectangle part, just this part of the relationship for brevity. So we have a new keyword which is called extend. So let's talk about how it's used. So we have our superclass, the geometric object. It's got some private member variables. It's got a couple of constructors and some methods, right? The circle class extends geometric object, right? And it's got its own constructors and methods, right? The keyword extends tells us, the compiler, that circle would be inheriting from geometric object, right? The constructor for circle can use the method setColor. So setColor is a method provided by geometric object, and the constructor is calling it. It doesn't define it itself, right? So it's only available to it because it has inherited it from geometric object, from the superclass, right? So a question here I ask here in this code is, can we take setColor and simply replace it with this dot color equal to C, right? And the answer is no, that is not possible. And the reason is because color is a private variable of a geometric object. It's only available to geometric object, and it really should be, we should be using the proper setter method here to set it, right? And that's an example of a nice abstraction, right? Okay, so before we had learned about various kind of relationship, a hazard relationship, aggregation, composition, association, and inheritance is a type relationship. A circle is a geometric object, right? In Java, we only have what's called single inheritance. A class can only inherit from a single other class, right? Other programming languages, such as C++, do have multiple inheritance, where you can inherit from two different classes with its own set of complications, right? Java only has single inheritance. Another reminder, this is used to refer to the object itself, right? So sometimes we need to refer to the object itself. especially when a parameter hides it, or you want to call another variant of your own constructor, we need to use this. This was covered in a previous lesson. Okay, so now we introduce another keyword called super. Now, super is used to refer to your superclass, right? And you can use it to refer to the constructors and methods of the superclass. So here's an example. In this example, circle has extended geometric object. And we have a constructor for circle. Now, instead of repeating code, circle would want to use the constructor that's provided by geometric object that sets the color and the position x and y, right? And if you go back to the code here, this is the constructor that the geometric object provides that nicely lets you set the color and the x and y position. And so instead of the constructor having to do that individually, you should just be able to call the constructor. And that's exactly what is happening here. Now there are some constraints. The call to the superclass constructor must be the first statement in the subclasses constructor, right? In fact, even if you did not explicitly call the superclass constructor, Java is automatically, implicitly putting a call to super as the first statement anyway, right? So it calls the version of super that has no arguments, right? Something like this, where a constructor is setting radius to 1, is really what's happening under the covers is that it is calling the superclass of circle first, right? So this is called constructor chaining, because this will keep on happening if there's a long chain of inheritance where superclass, and then subclass. It will keep on going back and calling the superclass constructor, right? So you should always define a no-arg constructor for your superclass to not have compilation errors, right? So that is something you should keep in mind, right? So just like you can use super to call the constructor, you can also use super to call a method provided by the superclass, such as super get color in this case. All right. Let's talk about a couple of more concepts before we look at some code. So method overriding is the act of redefining a method that is already defined in a superclass, right? So this method that you are redefining must have the same signature, right? And return type as the method in the superclass, right? This is called method overriding, right? So let's look at a code example. So here we have our superclass geometric object. It has a single method shown here, which is toString. ToString is a convention typically used to give a string representation of that object. It's a good method available for debugging and printing what the object might look like, what's inside the object, right? Circle extends geometric object and overrides toString. In fact, it's overriding it, and it uses the toString provided by the superclass in its own implementation. So the toString for geometric object prints the date, not prints, but returns the string with the date created and color. And here circle uses that, but adds a radius along with it, right? So we know overloading. Now, overloading is very different from overriding. Overloading is defining several methods with the same name, right? But with different signatures. Overriding is providing a new implementation of something that was available in the superclass, right? It must have the same signature. It must have the same return type, right? Just like toString, there's something called equals that compares two objects. Is another useful method to override. Note that since objects are stored by reference, if you use equal to compare them, you're just going to be comparing their locations in memory. If If you really want to compare the member variables, you implement an equals method to do that. Now, let's talk about polymorphism, another interesting concept, right? So there are really three pillars in object-oriented programming. There's encapsulation, which we have spoken in other lessons, inheritance, where we just spoke about, and polymorphism refers to an object really to take up many forms, an object to be able to use objects in very flexible ways, right? Specifically, it is when a superclass is used, where to refer to a subclass. Best explained with an example. So let's see what's happening here. We have a test program, we have main class, and we have our main method here, right? And then we have an additional method that we have defined called show object. Now, show object takes a single argument, which is of type geometric object, right? And then goes ahead and prints out the details, time created and position and color, right? Now here we're creating this circle, three circle variables. Now circle, if you remember, is a subclass of geometric object, right? Now we call show object, the method here, with the variables. Know that this is the data type of circle is the circle class, right? Now here, the parameter that it's taking, the data type here is geometric object, and it's perfectly legal to do that, right? An object of a subclass type can be used anywhere a superclass is used. So object of type circle can be used anywhere where geometric object is used, right? So this is what it's called polymorphism. So every circle is a geometric object. Now, every geometric object might not be a circle. Like, for example, a rectangle is not a circle. So this is the ability to use an object of a subclass type anywhere where a superclass is used is called polymorphism, right? So with that, let's actually look at our code, right? So far, all the concepts here are demonstrated with this code. So we have our original super class called geometric object that has some useful things that are useful across various types of geometric objects. It has two constructors, right, that are useful, and some getter and setter that would be generally applicable. In circle, we extend geometric object with the notions needed for a circle, like radius. We have a couple of different constructors. Here is the example of a constructor where we are using super, right? We might additionally want to set the radius to be r, right? And then we have other methods that are more specific to the circle. Getting and setting radius, calculating area and perimeter are very specific to how we do it for circles. In our test program, we create 3 circles with 3 different type of constructors for circle. And then we use show object, which was the example of polymorphism that we just talked about, where it takes an argument which is geometric object type, but we're passing in things of circle type. This is what's called polymorphism. And then if I print it, you'll get a kind of a string representation of the 3 objects. There. Okay, let's move on. Now we get into a couple of final concepts, right? There's a notion called dynamic binding. So let's consider this code here, right? We have declared a variable of type geometric object. Because of polymorphism, we can set it to an object of type circle. Create a circle and assign it to it. Now let's say we print the toString, what's returned by the toString method of obj. Now the interesting question is, toString is provided at multiple levels. It's provided by geometric object, and it's also provided by the circle object. which toString is it going to print. Is it going to use the one for geometric object, or is it going to use the one for circle, right? So the JVM, Java JVM, determines this dynamically using something called dynamic binding, right? Basically, it searches for the most specific toString implementation. So it starts, it knows that there's geometric object and there's circle, and there might be even a longer hierarchy, right? So it navigates the hierarchy and searches from the most specific, right? From the most specific subclass. So in this case, it's circle, and looks for a toString there. If it doesn't find it, then it kind of keeps going down to superclasses, and it uses the most specific version of toString. So it dynamically finds it. Even though what you're passing in seems like a geometric object data type, it will actually dynamically find the most specific one, right? We also have another visibility modifier called protected. You are already familiar with public and private. Public is for if you declare member variables or methods public, then they are generally accessible by everybody. If it's private, then it's only accessible within the same class. Now, protected visibility modifier is somewhere in the middle. If you use that, the variable or method that is protected is only accessible in the class itself and any subclasses. So here is an example in UML and in Java. Here we have a new private variable called last modified, right? And there it is in code. And we might want to define a protected method called last modified to store when was the last time this object was changed, right? So this method, last modified, can only be called by geometric object itself or any subclass of it. There may be cases where you do not want a class to be extended, or you do not want your method to be overridden by subclasses, right? So in these cases, you can use the new keyword final to prevent this from happening. So for example, if you have your circle class and you do not want any other classes extending it, you will put the final here. That'll prevent it from being extended. Similarly, for methods, if you use the word final, those methods cannot be overridden in subclasses. All right. So this has been a lesson on object-oriented programming, especially inheritance and polymorphism. Thank you.